negative 0.02 x to the fourth plus 0.28 x to the third. Am I correct? Am I copying the correct function? Always keep an eye on that. 3x squared. And then plus 20, correct?
Yes, over the interval of 3 to 12.
3 to 12. And they say 4 subintervals.
Yes.
Perfect. Great. Okay, so we will divide the interval between 3 and 12 into 4 subintervals of the same width. So how do I determine that delta x? In other words, the width of each subinterval. b minus a divided by n. So this is a comma b. So 12 minus 3 is 9 divided by 4. So this is 9 divided by 4. And so 4 subintervals. So this is this width here is 9 over 4, this one is 9 over 4, this one is 9 over 4, and this one is 9 over 4 between every point. So now the middle, 9 over 4 divided 9 divided by 4, so this will be the exact middle. So now we have to determine these points. Now it depends on what you want to use. If you want to use the leftmost point, then we will have to use these. If we want to use the rightmost point, then we will use this, 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 and this. If we want to use the midpoint, I'm going to use a different color, then I have this. Which one did you use? Anyone? It doesn't matter. Do you want to use the leftmost point, you want to use the rightmost point, or you want to use the midpoint? So leftmost point, rightmost point, midpoint.
Can we do the midpoint?
Midpoint it is.
Yeah.
Perfect, that's fine. So the midpoint, so first of all I have to determine these values. So what is 9 divided by 4 divided by 2? So this is 9 over 8. So now this piece is 9 over 8, and all these pieces are 9 over 8, and so on and so forth. So in order to determine, so this is, the first one is 3 plus 9 over 8. 3 plus 9 over 8 will be the first point. So this is number 1. So 8 times 3 is 24. 24 plus 9 divided by 8, this is 33 over 8. So the area with mid 4 will be, the width of the subinterval will stay in front. And now I have to have here 4 values. F of this value, F of this value, and I have to determine them. But the first one is G of 33 over 8 plus. This one is 1, 2, 3. So 3 plus 3, 9 over 8. So 3 plus 3 times 9 over 8. So this is 24 plus 27 divided by 8. And this is 51 over 8. G of 51 over 8. So this is number 2. 2 is 51 over 8, and I have to plug it in the function. Plus, I still have these two. So 1, 2, 3, 4, 5. So this time I have 3 plus 5 times 9 over 8. Still 24 plus 45, 5 times 9 divided by 8. So 69 over 8. So G of 69 over 8 plus. And of course I always run out of room, so I'm going to write the plus here. And remove that bracket so it doesn't confuse anyone. Hopefully you look at this again. Okay, so now I have to determine 1, 2, 3, 4, 5, 6, 7. So 3 plus 7, 9 over 8. So 3 plus 7 times 9 over 8 is 24. 63 divided by 8. Okay, what is this? So this is 87 over 8. Done. So that's the last one here is G of 87 over 8. Okay, perfect. So how I do this, I'm just going to share my screen so I can show you with the graphing calculator. So where are you guys? I see you. Okay. Okay, I'm there. Good. So here is what I would do. In edit, I will put in, I will clear my tables. I don't need my tables anymore. I clear them. So I will enter these four numbers. 33 divided by 8. Then I will enter 51 divided by 8. I will enter 69 divided by 8. And I will enter 87 divided by 8. Then I will go to list L2, highlight the name of the list, and now I will write 9 over 4 in parentheses in front. And then I will multiply by second list L1. And this will multiply, I have to put the function in, sorry. So 9 over 4 is in front, still. And then in parentheses, the function, negative 0.0. There is another way of entering the function, but let's enter it like this for now, and I can show you another one. So I have list L1. I didn't mean that. Back to the table. Please cooperate. But it's me, it's not the computer, the calculator. So we have again 9 over 4, I need it in front. 9 divided by 4. The left parenthesis, negative 0.02, I mean entering the function, multiplied by second list L1 to power 4. You can do this by hand, I just want to show you a different way. So plus 0.28 multiplied by list L1 raised to power 3, and then minus 0.03 multiplied by list L1 squared, and finally plus 20. Close the parenthesis, and now look what happens. Once I click enter, the calculator will calculate all these numbers in a blink. Boom. All I have to do now is add up these numbers, and that's the sum of base times height. Here's how I do that. I exit, stats, calculations, one variable stats for list L2. And give me the sum. Yay, here it is, 154.811. Any questions? I'm sorry, I read the mean instead of the sum. 619.2474. Here's the sum. 619.2474. However, now we can check. So let me copy my answer, assuming I entered everything correctly, 61924, and I will check this in a blink. Very easy, because now we have the information and we know how to do this. Let's do it. So the exact, so this is not going to be exactly what I'm going to get here, but the exact area is the integral from 3 to 12 from this function. Well, let's do that. Now we have the exact, which will not be exactly that. It will be the exact. This is an approximation. So negative 0.02 x to the fourth plus 0.28 x cubed minus 0.3 x squared plus 20. Of course, dx. No integral exists without dx or dy or dt, depending on what the variable is. Okay, so let's do this. So what function prime is x to the fourth? Can anyone help?
Professor, can you switch your screen back to your...
That would be nice, isn't it? Wouldn't be? Oh my god, sorry. So the exact, so I wrote what I did. My apologies. What I did, I wrote this here. I'm assuming that all my numbers are correct, but I will check. I can go back and just calculate with the leftmost point or the rightmost point. The midpoint should give us the better approximation. But you're right, the problem doesn't say. It doesn't say to use the leftmost point, rightmost point. Okay. So now we can determine this exact, which will not be this number. This is an approximation using 4 subintervals. And this is the exact carved in stone fixed answer. And this will be the correct one. Okay, so which function prime is x to the fourth?
X to the fifth over 5.
Excellent. Plus 0.28. Who was that, Amanda? Thank you. Which function prime is x to the third? Anyone?
X to the fourth over 4.
Great job. So I'm here now. Minus 0.3 times x to the
Third.
very good over 3 plus which function prime is 20?
20x.
That's it. From 3 to 12. So now I'm going to enter this function as is. I can simplify it a little bit so I don't have fractions, and I will plug in 12 and I will plug in 3. When I plug in 12 I will get blah blah blah, and when I plug in 3 I'll get whatever. So, and then I'll subtract them. So I'm going to divide 0.004 x to the fifth. This is 0.07. So plus 0.07 x to the fourth. This is minus 0.1 x cubed plus 20x. From 3 to 12. Check my numbers. I think I'm okay. And this I'm okay too. Yes. So I'm going to enter this function in the calculator, evaluate it at 12, evaluate it at 3, and subtract. What I get from the first one minus what I get for the second one. I'm going to share my screen again. So in y equals, clear if you have anything else. So now I have negative 0.004 x to the fifth power. That's how we check and catch mistakes. Now we have the option. So x to the fourth power and minus, and that explains why we're doing this. And I'm going to come back to it right when we finish this problem. And then plus 20x. And I go to second and table. Let me just make sure that I copied everything. I think I'm okay. Second and table. I will plug in 12. Enter. I will plug in 3. Enter. I will copy the numbers. I copy the top one 523.39 and the other one 61.998. I'm going to stop sharing. So this is the exact number, whatever it is. So obviously I have some calculation error on the approximation. So I got 461.392. This is the absolute exact number and the correct number. So obviously what I got here is not correct. I have to redo my calculations. So let's see what I did. This was 9/4, correct? Is 12 minus 3, 9, 4 subintervals? I think that's correct. So between 3 and 12. So this was 9/4 divided by 2. Yes, that's correct. It's 9/8. Then 9/4 stays outside. Then I determined this point, and this point is 3 plus 9/8. 24 plus 9. Still 33/8. That's correct. Then 51. So let's see how I got 51. 1, 2, 3. Yes.
I have a question.
Yes.
For the scale, going back to the scale thing between like 3 and 12, your number line. No, you were just. Yeah. If you divide, if the interval is given as between 3 and 12, that means you have 9 spaces total, right? So then you divided that by 4. So wouldn't you just add like 9/4 at 3 different spaces going forward? Like, I don't understand the 9/8 part.
So, is this clear that the distance between this point and this point is 9/4?
Yeah.
So this is right in the middle. So this point is basically 3 times half of 9/4.
Oh, I just confused myself. You're doing the midpoint, sorry. I was thinking about the...
That's okay. I'm always happy to go back and check because maybe you see something I don't. So I'm doing the midpoint. We decided to do the midpoint. So so if this length is 9/4, the numbers are weird because we all these fractions, right? So this is 9/4. This must be half of it. So 9/4 divided by 2 will be 9/8. So every half piece here is 9/8. Is that okay?
Yeah, I'm following.
Do you see something I don't? Maybe you do, and please let me know. Okay, then the next one is 1, 2, 3. So it's 3 plus 3. And the next one is 1, 2, 3, 4, 5. And then the last one, 7. Yes, okay, so I'm checking my numbers. So I don't want to spend too much time on this. I can verify this and tell you where I found the error. But I'm just checking here. That's 27. That's still 24. And that's 51. So that's okay. Then here, 45. That's still 24. So this is 69. I think this is okay. And the last one, this is 63, 24, and this is still 87. So all these numbers are correct. It's possible that when I entered it in the calculator. So I'm gonna do it in a different way. Since so another possibility. Let me share my screen so I can.
Professor Lena, I think the smoke alarm is going off in my building, so I'm gonna go. I'll try and get that phone.
Yes, please take care of yourself.